Why is VIF called the variance inflation factor? Well, the term inflation comes from the fact that if you take the ratio between the variance of the estimate of beta and the variance of the estimate of beta in a decorrelated model, then we just get the variance inflation factor. Now, what is a decorrelated model? It's a hypothetical model where all other x variables are not correlated to xj or to the intercept. So usually our variance of beta j is this formula. In the decorrelated model, the second term here is 1. So I just have sigma squared. If you had to guess what the minimal variance was, you might guess this, but it's still not completely obvious. So taking the square root here to get the standard error of beta j, the estimator, and well, you just get a sigma here. You get this additional factor. The length of a confidence interval is 2 times the corresponding t-value times the standard error. So I get this formula here and that over there. I take the ratio of these two formulas now. The ratio here, then a whole bunch of things cancel out. And we are left with the square root of this matrix. Well, it's just one element here, which is the square root of the variance inflation factor. So variance inflation factor corresponding to variable xj is also the square of the factor by which the confidence interval for beta will be inflated relative to the smallest possible confidence interval, which corresponds to the decorrelated model. So variance inflation factor tells you how far you are away from a perfect world. The perfect world is 1, multiply by 1. And if you have a variance inflation factor of 5, then your confidence interval is square root of 5 times larger than it could be in a perfect world. All right, we will not show how to decorrelate 1 and xj from the remaining variables. I had this in past offerings, but I think it's going too far for what we're trying to do here. Okay, that's it for this segment.